Hi there, we're looking a little more in depth at the X-rail system for linear movement in this short video. So we're looking at the three different options and sizes. We've got the smallest of the group, which is the 20s. This is a 20T rail. You can see on the end there you've got the profile. It's captive within those sliders so that they're not just going to pull themselves away. Moving over to the medium size, the 30s, we've got an examples of the T again here, and the slave version, which is the U rail, so the medium of the group, and then moving all the way over to the biggest of the group, which is the 45s. This is an example of a 45T. We've got these available in standard metre lengths, which is what you're seeing here. We carry these in stock usually up to 1 metre, 2 metres and 3 metres, or just slightly over those. But we'll also cut them to your requirements, so if you've got a much shorter length in requirement, we can work with that, it's not a problem. You've got the standard material here being low cost. You've got the zinc plated finishes, which I'm showing here in the 20 and the 30s here, but you've also got options which is quite useful in 316 grade stainless. So the one on the end here, you're seeing both the rail itself and the slider being changed over for stainless versions. Quite useful if you're working with an application that's going to see a lot of wiping down or might see a bit of external use, where the zinc plated versions that you're seeing of the normal low cost versions are just not going to be suitable. So we'll move over to stainless in that sort of regard, but the same availability we'd expect there as well. Basically the X-rail system works unlike a monorail where it's running on a slave and a master system. So the 30 here is seeing the counterpart, the master here, and the slave. So we'd see these mounted typically in this orientation, where the load is being pushed down onto the rail by those sliders. You can see the profile of the T system keeps this slider captive, so it can't physically be removed. The accuracy of this system is typically a fair bit lower than when you're expecting something from the monorail. The beauty of it being is that it allows a misalignment adjustment. So if you're not going to go to the expense of machining your workpiece down to get the accuracy, then a system using a slave and master system is going to be far more appropriate. You've then got the slave system, which, as you can see there, is more of a channel. It's not going to be captive in the same regard, which allows, when you're moving that sliding system, it allows you to move it in and out of the rail by a few millimetres. The 30 system anywhere between 3 to 5 millimetres or so, depending on the system. But imagine if you've got the system in parallel and there is some slight movement there over 3 metres, 4 metres. The ability for the system to account for that parallelism is what makes that a much easier installation. It doesn't require you to do all the extra work that a typical monorail system would do. So certainly an advantage in terms of cost of installation, not just on the system itself, but moving forward down to the actual approach of how you intend to install the system. You've then got the sliders themselves. You might notice that the little 20 here is using a slightly different system. We've got the low profiles rather than the standard bodies. These are the quite standard bodies you're seeing there. They're not particularly chunky at all, but some people would prefer to use a much lower profile system. Just be aware that that lower profile slider is only available on the T system. On the U, the low profile is just going to snag on the housing here, so if you are using a typical slave and master, you often see these, the standard bodies, being used over the low profiles. If you're intending just to use a T system, then by all means have a look at those low profile systems. Again, they work on the same principle of adjustment. It's just a case of that main body is a lot flush to that system than the main. So with the X-rail system, they're running on a set of rollers. For these, you've got 3 rollers. The ones marked at the end here, you can see the tiny little pips there, are showing that these sets are fixed, so we can't adjust these, they're in that position permanently. The centre one here is eccentric, so we can alter that roller's position, very, very fine tune it either up or down to add or remove preload onto that rail. So how much force it requires to actually roll up and down that rail. This one, for example, has been set fairly high, so it's taking a little bit of force to move it up and down that rail, whereas you can have them run quite smoothly, requiring very little force. You have to be a little careful that it doesn't shake. If it's been removed, the preload's too low, it's not captive in that rail. It's not holding itself in there nicely. You can see on this one, it's sitting quite well. So any lighter than that, and you risk it not being calibrated correctly into that rail. It's quite easy to change the roller system. We put a spanner in there, and we can tighten or lighten the overall position of that roller within that rail. So if we suddenly pop it back on, it's now tightened to the point that you can barely even move it. So that's now potentially a little bit too tight. So you can fine tune that. Once you have your load placed onto it, you can fine tune that in sight to have the smoothest roll appropriate for your application. Looking at the actual loading capacity between the systems, the 20s, 30s and 40s as we said earlier. The 20, typically we'd expect, even though it's quite a small size, those sliders have a radial, and bear in mind we're talking radial rather than axial load, the way it's pushing down straight on the rail. Each one of those sliders, somewhere in the ballpark of about 30 kilos of expected weight there. So assume you're working on a slave and master where you've got a pair of them, and you're normally using 4 sliders in configuration to stop the system creeping in one way or the other. So you're suddenly talking about the smallest rail system in a cost-effective solution able to take in the ballpark of about 120 kilos there. Moving up, each individual slider here, somewhere in the region of about 80 kilos. So suddenly 4 sliders in configuration, somewhere in the ballpark 320, and then all the way up to the biggest, pushing on to 680, 700 kilos. So you've suddenly got quite a fair bit of radial force being worked in a low profile system, or a low cost solution rather. So really, it can take quite a fair bit of load without having to be as accurate as some of our other systems that you're seeing there. So if you're looking for something with, quite a fair radial load, but you're not seeing a huge amount of movement or speed of movement, and the moment force isn't particularly high, and you don't want the expense that you're seeing of some of the other systems or the accuracy of some of the other systems, it could be a solution that you want to consider.